So chapter 16 gets into the actual techniques for integration, and we're just going to get into the specifics. And it's really using your fundamental theorem of calculus that we've been using. And what this starts to talk about, remember how I was talking about that plus c is the constant of integration? This is where they formally introduce it. It's also called an indefinite. If there's no numbers here to evaluate, this is your indefinite because it's just for everything. So these are just some more rules. We've talked about this. If you have a constant times a function, you can pull that constant on the outside of the integral and take it times the constant times the integral itself. This is all just stuff we've been doing. If you're adding or subtracting individual functions, you can add or subtract their individual integrals. This just shows a proof of why it works. It says if you're differentiating k times f of x, where f prime of x equals little f of x, you take the derivative of this, you get k times the derivative, where k equals, the derivative is little f of x. This is just a proof. Now the examples themselves are a whole lot easier. Now, what this is saying, I don't agree with this part, and you're not really going to have to do this, but they're just saying if you take the derivative of x to the fourth plus 2x to the third, and it is kind of good to kind of do the derivative and antiderivatives at the same time, so you get used to that. But the derivative, bring it down the power rule, subtract 1, multiply, subtract 1, that's the derivative. Hence just means we're going to use this information, but you don't need to really. Because when we do the integral, we're just doing the inverse and we do add 1 and divide, add 1 and divide, plus c, always, if there's no values here. And then we just simplify. So 2 over 4 is really 1/2. And you can either write that as 1/2 or x to the fourth over 2. The 3's cancel, so just x to the third plus c. Okay. All right. Did I do this twice? Oops, I copied one twice. Okay, so the derivative of cosine so if we do the derivative, now this is where you're really blessed because you get to use your formula booklet. So the derivative of cosine is negative sine and then we chain on the derivative of the inside, which is 2. The best way to write that is negative 2 sine. Okay, so your derivative, you're just straight out derivative. The integral. So it's kind of funny. So the derivative of sine is positive cosine. So the antiderivative of positive cosine is positive sine. So when you go backwards, sine is, the derivative of sine is positive. The antiderivative of cosine is positive. Because the derivative of cosine is negative sine, the antiderivative of sine is negative cosine. So it's kind of backwards, if you just can kind of remember they're backwards. So antiderivative of sine is negative cosine. But I would just definitely keep your formula booklet because it tells you all of this. You don't need to guess. And when we chain on for the antiderivative, we divide. And what I would do instead of dividing by 2, I would just always make that a fraction out front because it just looks awkward when you take cosine and divide it by 2, but it looks more normal to have negative 1/2 times cosine. And that's letter A.